Hi, kids. Don't you get tired of me starting like that? Hi, kids.
Hello, students. It's time to learn math.
Hi, boys and girls. Oh, that's just creepy. All right, so here we go, kids. Day 3. Nummer 3. Meine Studentin denkt, dass es ist sehr witzig, wenn ich Deutsch mit alle reden, was sie kann gar nicht von mir verstehen. Wahrscheinlich die deutschen Leute können auch gar nicht von mir verstehen. Was that fun? A little German for you, huh? I said, oh, there's my dog. He must have saw, like, my neighbor. Do you hear him barking? He's so much fun. At any rate, let's get started. By the way, what I said was my kids think it's funny when I speak German. They don't understand a word I'm saying, and I doubt even the Germans understood what I was saying. But anyway, I didn't even clean my glasses. And maybe in the next video, see my hair shaved. Gotta get a haircut. Oh my God, my beard is growing like I feel like a lumberjack. If you remember yesterday, we did something like 2 cubed equals 8. And then it's all about that base, It's all about that base, Oh yeah. To change forms, we're going to change forms. We're going to do log, keep the base, switch the other stuff. Log base 2 of 8 is equal to 3. All right, let's do this. So we're going to change base every time our variable is an exponent. So we're simply going to change the base. Or not change the base, but change the form. So log,
It's all about that base, all about that base, yeah.
God, I know what you're thinking. Probably should have been a rock star. With looks like this, I should be in radio. At any rate, keep the base. All about that base. And then these two, we flip-flop. Log base 6 of 27 is equal to x. Grab the old Taschenrechner. We hit log base 6 of, was it 27, I believe? Log base 6 of 27 is 1.8. What did it tell us to round? It did tell us to round here because this is kind of annoying. Hundredths place if necessary. So 1.84. 1.84 equals x. 1 down, 400 to go. Oh my God, 23 to go. This is going to be forever. All right, get the weird thing alone. So the first thing we're going to do is move that 8 over. So we get 6e to the 0.25x equals 12. Divide by 2, we get e to the 0.25x equals 2. Now, it's all about that base, but in this case, the base is e. And anytime the base is e, we're going to use the natural log. Now, we can do the natural log of base e, but remember, this is not necessary. And then these two things change. So natural log of 2 is equal to 0.25x. Divide by 0.25. Divide by 0.25. Let's change colors. 0.25 and jetzt wir müssen unser Taschenrechner benutzen. And now we have to use our calculator. So we're going to go natural log of 2 divided by the way, I think most of you that are smart, I'm dividing by 0.25, right? At some point, those of you that are smart need to remember that when we're dividing by 0.25, what we're really doing is multiplying by 4. And multiplying by 4 would be a lot easier than dividing by 0.25. But anyway, it's 2.77. X is equal to 2.77. All right. It's all about that base. There's the base. And flip these. 72 equals x. Oh my God, Kraus, are you so freaking serious, man? I'm like, this is so... Oh, what am I in? Kraus, you don't even know what you're doing, man. All right. Log base 5 of 72. We're going to round 100s place. 2.66. x equals 2.66. Now, you know, you could always check these. I could be like, well, in this case, it should make sense, right? But I could always check it. 5 raised to the 2.66. It better be close to 72.3. It's close. All right, get the weird thing alone. E to the 0.5x equals 3. Oh, 3e. Divide by 3, and I get e to the 0.05 equals 1. Now, at this point, you ought to you really know that this has to be 0, because anything raised to the first power is 0. But let's say you didn't and you wanted to change the base. Good answer, Bob. Okay, I've been up for a while. I probably need a nap. I'm not going to lie. And Brugers, thanks. I appreciate it. A little jittery. Not going to lie. Okay, so natural log of e, but we don't need e, of 1 is equal to 0.5x. Now, the natural log of 1 is just 0. Divide by 0.5, divide by 0.5, and I get x equals 0, as if, I'm not going to bother doing that calculation. You should know the natural log of 1 is 0. Remember, logarithm functions always go through the point 1, 0. All right. Change the base. Oh, we're going to change the form. So it's all about that base. Copy over the base. 5. And then these two change places. Squared equals 3x minus 8. Thank goodness I don't need my calculator on this one. This is 25 plus 8. So that's 33 equals 3x. Or x equals 11. Now the base here is 10. So we're going to change the form. 10 squared is equal to x plus 1. Well, hopefully you know 10 squared is 100. 100 minus 1 is 99. X equals 99. 99 loof balloons. All right, so in this particular case, this is the And the reason I say that, it should become pretty obvious. What's x? Oh, 2. What's x? Oh, x equals 2. What's x? X equals 7. I mean, like, you can just look at it and go, well, if that's 2/3, that has to be 2/3. If that's 5 squared, that has to be 5 squared. And if that's log of 7, that has to be log of 7. Okay, let's just... Where'd my other easy ones go? Oh, they're down there. Is these out of order? We'll get back to it, I guess. I thought these were supposed... I think this is out of order. I think these are supposed to go... Well, they're numbered right, but I know they're out of order, so I'm going to have to remember to do those differently. So, this stuff that we just learned that was duh, just remember that. Just remember it, because we're going to use it way down there. So, we'll come back to it. Okay. Oh, well, no, actually, I can use that idea here. Let's use that idea here. I apologize. Like, let's go back to this one right here. How come I knew that that was 2? Because as long as if the bases are the same, as long as the exponents are the same, then they have to be equal. And that's what we're going to do in this next step. We've got all these bases. We've got 3 and 9. They're not the same. They're not the same base. If they were, all I'd have to do is set their numerators equal to each other. But, excuse me, I'd have to set their exponents equal to each other. So what we do is we want to change the way this one looks. This one's fine. It's as low as it can go. 3 to the 7x minus 3. Let me stop screwing around for a minute. What we're going to do is we're going to transform 9 into a 3. And you all should know that 9 is really equal to 3 squared. So what I'm going to do is I'm going to replace the 9 with 3 squared raised to the 2x. Now, if you remember correctly from before, these just get multiplied. So what I really have here is 3 to the 7x minus 3 is equal to 3 to the 4x. Well, now that the bases are the same, all I have to do is take the exponents and set them equal to each other. So what we get is 7x minus 3 equals 4x. I'll bring the 4x over here. So I get 3x. And then I'm going to move that 3 over there equals 3. Or in this case, x equals 1. Now this is really, really easy to test. I can either test using my calculator, or I can just come over here and use my brain. This becomes 3 to the 7 times 1 minus 3. In other words, this becomes 3 to the 4th. And on the right, I get 9 squared, because I just put a 1 in there. So 3 to the 4th is 81, 9 squared is 81. So what we're going to do is we're going to transform them down into 2, 3, or 5 bases. Now, there one might be a case where you might use 6 or 7, but generally not. Generally, we want to get something down to 2, 3, or 5. Those are prime numbers, and they're the smallest base, and they're easy bases to deal with. So pretty much, if it's even, we're going to use 2. If it's odd, we're going to use 3. And if it's a multiple of 5, we'll use 5. Now, let me tell you what I mean by that. I see even. So I want to change 64. So it's 2, let's see, 2, 4, 8, 16, 32, 64. 2 to the 6th power. You'll get better at this. 2 to the 6th power. So 2 to the 6x. Remember, whatever we replace it with, we're going to multiply by, is equal to 2 to the 2, 4, 8, 16. 2 to the 4th times x plus 1. Now notice I put this x plus 1 in parentheses. I should have put it in parentheses here. Otherwise, I might end up with 4x plus 1, and I think you should see that this is really 4x plus 4. Okay, well, if that's true, then what I should have is 6x equals 4 times x plus 1. All I'm going to do is set these equal to each other and solve. So I get 6x is equal to 4x plus 4. 2x is equal to 4, or x equals 2. Now this one may not be as easy to check because I don't know what 64 squared is, but I could certainly plug this back in using my calculator. This is 64 to the x is 2. Does that equal 16? And if I put in a 2 here, I get 3. Does 64 squared equal 16 cubed? And it does. And it's easy. So let's go back. If it's odd, we're going to use 3. If it's even, we're going to use 2. And if it's a multiple of 5, we'll use 5. Well, this one's easy. It's a multiple of 5. So this, we're not going to change, but we are going to put that x plus 2 in parentheses, is equal to 5 squared times x. Set the exponents equal to each other. You get 5, what am I talking about? X plus 2 equals 2x. Or x equals 2. Over here, replace this with a 2. This is 2 cubed times 2x. This is equal to 2 to the 4th. So what I end up with is 6x equals 4, or x equals 4 divided by 6, which is 2/3. Now that's confusing, so I'm going to try that one. 8 to the 2 times 2/3. Does that equal 16 to the, well, just 16. So I'm going to grab my calculator. 8 raised to the 2 times 2 divided by 3. 16. There it is. Ka-ching! It worked. All right, I'm going to come back to those fractional ones. Let me do this one down here. So this is just 7 to the x equals, now we got to replace 49. So I said 2, 3, 5, but here's a case where we're going to have to use 7 because I can't use 3. 7 squared times 8. Oh, well, x equals 16. Ka-ching, done. Here we got to take care of a little business. First, we got to take care of this multiplying. So this becomes 2. Now when we do this, we add the exponents. Don't forget that we add the exponents. So this becomes 2 to the 8x equals 2 to the 4th. Now 2 times 2 is 4. Times 2 is 8, times 2 is 16, so 2 to the 4th. Okay, so now I just set their exponents equal to 8x equals 4, or x equals 1/2. Now I'm going to test this back in the original. I'm going to plug in 1/2 here and 1/2 here. I'm going to do that using my calculator. First I'm going to do is I'm just going to take 1 divided by 2 and stow it into x, because I think this is so much easier. And then we're going to go 2 to the 3x, so 2 raised to the 3x times 2 raised to the 5x. And hopefully that's 16. There it is, 16. All right, so now let me tackle these two. There's only just two of them. Let me just tackle these two. I said before we're going to go to 2, 3, or 5. It looks like we might do 7 as well, but generally it's 2, 3, or 5. So when I look at these equations and I see base to an exponent, base to an exponent, I want to get the x bases the same first. So this one's easier. I know that this is 3 squared and then times 2x. This one is not so easy, but if this one's a 3, then this one has to be a 3. And you have to remember that if I have a fraction, that comes from having negative exponents. So think about to yourself, 3 to what power would give me 27? And I think you can all come up with 3 cubed. So to get 1 over 27, I just need a negative 3. So this becomes negative 3 to the negative 3 times 4. So what I have here is negative 12 equals 4x, or x equals negative 3. Now, I'm definitely going to check that one because, wow, that looks complicated. So, first things first, fraction 1 divided by 27 raised to the 4th. I don't know what that's equal to. There it is. Okay. Now, the other one was 9 raised to the 2x, and x was negative 3. So 9 raised to the 2 times negative 3. Same thing. All right, let's go back. Let's take a look. So this is already a base of 2, 2 to the x. This is just 1/2. Well, 1/2 is 2 to the some power is going to give me 1/2. Remember, that 2 just comes down there by putting a negative. So this is 2 to the negative 1 times x minus 2. Now, I should immediately have put that in parentheses, so I didn't do that. That's bad on me. So now I just set the exponents equal each other. Negative x plus 2, I distributed, is equal to x. Add the x over, I get 2 is equal to x. No, is equal to 2x. Or x is equal to 1. Now, let's see if that makes sense. That looks weird. So I'm going to try that. 1/2. So let's do 1 stow x. And then I'm going to do 1/2. Oops. 1 over, what in the heck is going on? Controlled division, 1 over 2 raised to the parentheses x minus 2 equals 2. And then the other side was just 2 to the 1. That's just 2. So yeah, it worked. Sweet. Now let's go back. Not back. My bases are the same. Log base 7, log base 7. In fact, all of this is the same as all of this. And you wouldn't have any problem if I wrote log base 18 of 5 is equal to log base 18 of, and what would you put here? If I said, I don't know what goes there, I have no idea, you'd say, duh, 5 goes there, because these two things have to be equal. Well, I have log base 7 and log base 7, so these two things have to be equal to each other. Or, another way to say that is 6x minus 16 has to equal x minus 1. Or 5x equals 15, or x equals 3. You're going to have to trust me. If I check that, that would work. Log base 6, this is the same as this. So these two things have to equal each other. So 2 minus x has to equal 5x. Or 6x is equal to 2, or x is equal to 1/3. If I divide both sides by 6, I get 2 over 6 is 1/3. I know you don't believe me. So control division 1 over 3 stow x. And let's see. Log base 6, so control log base 6 of 2 minus x equals some stupid number, and then log base 6 of 5x. Should hopefully be the same dumb number. There it is! Okay, kids, let's go back and learn our properties again. Log a times b. Oh yeah, that's log a plus log b. Log of x over y. Log x minus log y. Log of a to the b. Oh, that's b times log of a. And we start here always. If you have an exponent and we're doing the condensing or expanding, you start with exponents. Please, 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 please. Start with the exponent, please. All right. So, whoa. Let's back up the crazy train, girlfriend. This isn't a problem. I have addition. So we're going to revert back and condense this. We're going to condense it. Addition condenses back to a multiplication problem. So I'm going to rewrite this as one log. Log base 2 of x times x minus 2 equals 3. You know it's coming. Oh, you asked for it. It's all about that base. Ooh, it's all about that base. We have a logarithm question. In order to solve it, you need to change its form. So it's all about that base, So what we're going to do is we're going to take this base, 2, and then these two things switch places. Cubed is equal to x times x minus 2. Oh my God, looks like fun. It's a quadratic. So what I have here is 8 equals x squared minus 2x. Or x squared minus 2x minus 8 equals 0. I'm going to factor. Oh no, are you kidding? Factoring more? Can you believe log problems turn into functions, or factoring? It's so much fun. Oh my God, I love math. Plus 2. So my two answers are x equals negative 2 and x equals 4. Now, I will tell you, and I will tell you until you're blue in the face. You must check log questions. So, first things first, we're going to stow negative 2, stow x, and then we're going to type in control log base 2 of x plus control log base 2 of, was it x minus 2? And hopefully that equals 3. Whoa, let's back up the crazy train, girlfriend. What are we doing here? You're trying to take the log of a negative number. And if you remember correctly, let me take you back to the log functions. Log functions look like this. Agreed? You cannot take the log of a negative number. Gone. Now, in order to really check this, let's see if 4 works. I hope 4 works. Otherwise, we really mess something up. 3. There it is. So that one's got to go. All right. Now you got to be careful. You can't always cross off just a negative answer. That would be stupid. That doesn't always work. Sometimes negative answers work because, like, for example, if I put in, this is a bad example. This would be a bad example. But later on, I'll show you one where it's a good example. Like down over here, if I had -2 here, -2 plus 6 is 4. It's not a problem. I can take the log of 4, and I wouldn't even have to worry about this one. So sometimes negative answers actually work. It's when you plug it in, and then you end up having to try to take the log of a negative number that you run into problems. So don't think just because it's negative it has to. But you should be leery, but don't just think because it's negative you got to get rid of it. So log base 5. And now these two things, because there's addition, need to get multiplied. X plus 4 times x plus 1 equals 2. All about that base, about that base. So we're going to change the form by keeping the base, and then these two things change places. So squared equals, now I'm going to double distribute all this crud out here. X squared plus 5x plus 4. I'm going to bring the 25 over, so I'm going to subtract 25. So I get 0 is equal to x squared plus 5x minus 21. I didn't think I had any difficult ones like this. Five squared is equal to x squared plus 4 minus 1. Well, unfortunately, this doesn't factor. So the only way to solve this would be using the quadratic formula. So x is equal to -5 over 2 plus or minus the square root of the discriminant. In this case, the d would be 25 minus 4 times 1 times -21. I thought I didn't want to do this one, so let's just see. 25 minus 4 times -21. 109. So square roots of 109 over 2. Let's just leave it at that. I meant for that. I thought they all came out to be nice numbers. I apologize. All right, so let's keep going. Base is 6. We have two things that are being added, so we're going to change that to multiplication. 2x minus 6 times x equals 2. Every time you're going to sing it to yourself. It's all about that base. Got to shake your neck, too. Shake your neck. I said my hair is going to be cut before this video. I apologize. Next time. 6 squared, these are going to change places, is equal to 2x minus 6 times x. Or 36 is equal to 2x squared minus 6x. Bring everything to the right side. I get 2x squared minus 6x minus 36 equals 0. I will take out the 2. X squared minus 3x minus 18, or 0 is equal to, this is going to be x minus 6, x plus 3. So my two answers are x equals 6 and x equals 3. Wow, or -3. -3. So we should test those. So let's take 6. It's probably the one that's going to work. Don't know if the other one's going to work. And we're going to do log base 6 of 2x minus 6 plus log base 6 of, I believe it was just x. And we get 2. And we get 2. Yay. Now let's store -3. We start -3 in for x. And then I want to just highlight that line and do it again. Don't retype it. That's silly. Oh. We get non-real calculations. And once again, because you can't plug -3 in for here. So I should have even not bothered, because I know if I plug -3 in there, I'm taking the log of a negative, which is not possible. All right. You can pause it if you want, because I'm about to erase it so I have room for the next one. So anyway, let's take a look at this one. I should just blow this stuff up. Should show you guys one problem at a time. Oh my God, that's awesome. You guys can see that. So right here, you'll see I have subtraction. Now subtraction is going to go back to division. Whoa, whoa, alert, alert, alert. I have an exponent. Remember, we return exponents first, so that becomes this squared. It gets returned first. Must. So what I end up with is log base 2 of x plus 6 squared over 16. We're going to divide this thing and this thing get divided equals 2. Oh yeah, it's all about that base, So yeah, even with these problems, nothing changes. The base stays 2. These two things change places. Squared equals x plus 6 squared over 16. Now, I'm going to multiply both sides by 16 to get rid of that thing. And this is really 4. That's a squared, by the way. So I get 16 times 4 is 64 is equal to, and I'm going to expand this out, x squared plus 12x plus 36. That's this thing double distributed or foiled. So I get 0 is equal to x squared plus 12x minus, holy crap, 24, 28. So this factor is pretty easy. X plus 14, x minus 2. So my two answers are x equals negative 14 and x equals 2. Now, if I go back to the original and I plug in negative 14 there, I'm pretty sure you realize that's going to cancel. That's going to give me an error. But the 2 looks like it'll work. So we're going to do 2 stow x, and then we're going to do 2 log base 2 of x plus 6 minus log base 2 of 16. And it's 2, and we want it to be 2. Yay! 2 left, kids. 2 left. All right, so we have subtraction. Subtraction reverts or condenses to division. So log base 4 of x squared minus 4 all over x plus 2 equals 2. It's all about that base. So we get 4 squared is equal to x plus 2 x minus 2 all over x plus 2. Wait a second. Those cancel. So I end up with 16 is equal to x plus, or x, excuse me, x minus 2, or x equals 14, or 18. Well, I hope that works. So control log base 4 of 18 squared minus 4 minus log 4 of 18 plus 2, which is just 20. 2. Yay! Holy crapola. All right, let's try this. The good news is it's base 10, so that's pretty good. So we don't have to write the base on this one. So it's going to be log. Now, I could write base 10. Now, this is subtraction, so we're going to divide. X plus 5 over x minus 1 equals, oh, these are the easy ones that kids hate. X plus 2 all over x minus 3. Now, I have log. So you should be able to agree with me as long as this equals the green equals the green, they got to be the same. The green has to equal the green. Log of 5 equals log of 5. Log of 10 equals log of 10. So the greens have to equal each other. So all I do is set the greens equal to each other. X plus 5 over x minus 1 equals x plus 2 over x minus 3. Now, you can either cross multiply or multiply through by the common denominator. The common denominator is x minus 1, x minus 3. Of course, you could just cross multiply. We're going to end up basically cross multiplying anyway, because that cancels with that, and I double distribute this. X squared plus 2x minus 15 equals that cancels with that. X squared plus x minus 2. Now, the cool thing is, and the easy thing about this one is, the x squareds cancel. So I get x equals 13. If you solve it, you get x equals 13. Now, this is a pain in the neck to check, but check it. Don't be freaking lazy, kids. We don't need any more lazy people. Got enough lazy people in the world. So, 13, control var x. And then we're going to do log base 10 of, so log, control log. Now, you don't have to put the 10 in. X plus 5, because it's understood. You'll see it'll put it in there for us. Minus, control log, you don't have to put the base in, it'll put this in there, x minus 1. Now I'm going to get enter. I don't care what it is. And then I'm going to see it put the 10s in there for us. Control log, x plus 2. Minus, control log, x minus 3. Yes! It's so wonderful! Yay!
Yeah, it's all about that bass, about that bass. It's all about that bass, about that bass.
Oh, maybe I need to put my necklace on. My G money. Yeah. Yo, 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 it's all about that bass, yo, about that bass, yo, yo, yo. I am the biggest math nerd there is. Well, that's maybe not true. There are a few others. Anyway, kids, it's been fun having this time to share with you and learning logarithms and their properties. I hope I have enlightened you to be a logarithmic superstar. I'm going to miss you. It's been fun. Come join me again. Hit subscribe. Hit donate. Hit the commercials if they make sense. Anyway, love you and take care. Well, I don't love all of you. There's a few of you that are a little weird, but I like you. Bye.